So hi everyone, today we'll try to understand how we can reduce the size of a neural network using TensorFlow Lite by 1/10. So let's get started. So basically, there's a short backstory that I have. So I was dealing with the image classification problem. I built out a neural network and it was performing quite good. Like the accuracy was around 95%. And eventually, we were just going to deploy it. Then we came to know that the size of the model was nearly 750 MBs. Now deploying such a heavy model is painful, and like you really can't occupy that much of a space in the production servers. And eventually, I think if you have in the data science space for some time, so you might have heard of the Netflix competition, in which the first prize winners didn't the model that they created didn't got deployed because of its humongous size. So let's talk about how we can reduce the size of this big neural networks to some MBs. So basically, how we'll be reducing this? So we'll be following the idea of quantization. Uh, so what does quantization do? So quantization do nothing, but it tries to convert continuous values into some finite range of discrete values. Now rounding off, scaling, truncating decimal parts can be taken as a part of quantization. So for example, if you have value 68.1325 through, so in this case, the longer the decimal tail is, it is not adding much information to the final prediction, but it is occupying a lot of space. So eventually, by taking a slight hit on your results, you can reduce the model size by a lot. So we'll be using a special library called as TensorFlow Lite that will help us to reduce the model size by 1/10. So TensorFlow Lite also performs such quantization by converting 32-bit representations to 8-bit representations. Right. So let's get started. I will be trying to convert one of my models into a smaller version using TensorFlow Lite, and let's see what is the latency and what is the performance. First of all, you'll be importing TensorFlow and then using this particular code snippet tf.live.tf converter to from keras model file. I'll be loading my model. So basically, this particular function can be used to quantize a keras model. Now, if you wish to quantize some other different formats of model, you need to go to the documentation and figure out there are other methods as well. Now, the next is we are trying to set up the optimization for the converter that we wish to optimize for the size. There is another option called as we can optimize for the latency also. So there are two options present, but as our model size is huge and latency is not that big an issue, so I will be taking a hit on the latency and we'll be optimizing for size. Then we'll be converting the model and then saving it into a file with a extension .tflite. Do remember this. So basically, we have three steps. We first of all loaded a TensorFlow Keras model. We set up the optimization to optimize for the size, and eventually we converted the model, saved into a TensorFlow Lite file. Now, once the conversion is in, the conversion part was comparatively easy. Now we need to load this model, and then how to deploy this model and how this model can be used for future predictions. Let's see that. So basically, we'll be calling out an interpreter object from TensorFlow Lite that will be loading the converted model. So as you can see, I'm loading the converted model from my Google Drive, and using an interpreter object from TensorFlow Lite. I'm also providing the interpreter is getting the input details and output details. Now, a catch that you will see is key. The data is a training data set for is a test data set. So in this particular data, what we would be doing is that we would be passing one element at a time as a list. So basically, it is a single element list that we're passing to interpreter to get the results for us. So basically, as in case of a normal model, you can feed the whole test data set once and you are getting the results. In TensorFlow, you can't do that. You need to pass one instance at a time in form of a single list element. Then you need to invoke the interpreter and then get the output in this particular format. I think pretty much clear. So basically, the only limitation that I can see right now is you can't get a prediction for multiple outputs. You need to pass outputs one by one. Also, there are a few more limitations that I have observed. So let's first of all talk about the size of the model. So the model size that was 744 MBs has been reduced to 62 MBs now. So it is nearly 12 like one twelfth of the total size that I have. But now the latency for images has been increased a lot. So the final prediction made earlier was 100 images per second, but now it is 5 images per second. So we have taken a latency hit of 12. I think you are getting my point. So we have increased the latency by a factor of 12. So here you saw that basically we reduce the size, but we have taken a hit on the latency. So that's a catch that we need to maintain. Also, the accuracy has remained almost the same. that is 0.5%, like there is a change of 0.5 percentage, but the ROC AUC took a very heavy hit, like it went down from 0.89 to 0.82. So as you can see that the AUC ROC, the ROC AUC value has reduced a lot, but for the new reduced model, the accuracies remain the same. Now, why latency has increased? Let's understand that. So, TensorFlow Lite is basically made for Android and IoT devices, right? So that we can deploy a very heavy model on small devices, and that is why latency has increased. So, basically, the interpreter that we are calling searches for an ARM processor, basically, uh, and in a PC you won't be finding that, and hence that is what consuming the time for us. So basically, poor latency will be observed on laptops or on servers, but it won't be observed on IoT devices or mobile phones, because the invoke part, the interpreter dot invoke function that we're calling when we are trying for the when we are going for the prediction, as you can see here in this particular code snippet, that is taking a time. It is trying to search for the ARM processor, which is it is not able to find on the laptops. That is the whole case. That is what it is taking a lot of time. So hence, this is how you can reduce the model size. You will get a hit on latency, as well as you might also have a small hit on your metrics. But still, if it is not deployable, it is of no use. So hence, we need to bring everything into a particular threshold.